Okay, calculus, the last one for 10-1 is hyperbolas, and we're not going to do any deriving like we did for the other ones because deriving a hyperbola's formula is exactly the same as the ellipse. The only difference between a hyperbola and an ellipse is x squared and y squared have opposite signs. Okay, so hyperbola is the set of all points for whom, instead of the sum from the distance of the two foci is constant, it's the difference in distance to the two foci is constant. That's the absolute value of the difference. It's always a positive distance. So we had the circle where the two foci are exactly on top of each other, and as you pull the foci apart, you started to get an ellipse, which created an eccentricity between 0 and 1. Here your eccentricity is 0, here it's between 0 and 1. And then finally, if you pull them outside the shape entirely, the eccentricity gets bigger than 1, and it causes the shape to bend the other direction. Instead of going towards each other, they go the other direction, which is what a hyperbola is. It looks kind of like a two-sided parabola, but function-wise, it's not really much like a parabola. Hyperbolas have the exact same features as ellipses. They have a focus, two foci, a center, 4 vertices, but really only 2. We use the other ones, but not for graphing purposes. We only really use the major axis for graphing purposes, and the major axis could be larger or smaller. That's a different argument. And they have eccentricity, but theirs is always bigger than 1. The form of their equations is exactly the same as circles, except the only difference is there's a minus between them instead of a plus. Now, whichever one is your leading term, and if you end up dividing by a negative number, that could change the order. That is the direction the hyperbola is open in. If x is your positive and y is the negative one, it'll open left or right. And this is when you're all done completing the square. If y is the positive one and x is the negative, it opens up and down. Now, graphing these is actually not that bad. So we're just going to practice graphing these. You plot the center and the vertices. You make a box of dotted lines. You're like, what does that even mean? We'll talk about that in a second. You draw slant asymptotes, which are going to be diagonals through the corners of the box. And then from there, you graph. Okay, so let's start by finding the center. We're going to do 4b, which is the last one there. The center is the HK. Now notice x doesn't go anywhere, so the center there is 0. Since it's y plus 2, it's negative 2. So we have 0, negative 2. I'm going to graph that here, over 0, down 2. Now I need to figure out where my vertices are. So where are my vertices? I could either go out 3, because it's the square root of 9, in the x direction. So that'd be 3, negative 2, or negative 3, negative 2. 3 in the x direction. Or I can go out 7 in the y direction. So that would be 0, negative 9, or 0, 5. So 0 down, 1, 2, 3, 4, 5, 6, 7. Or up 1, 2, 3, 4, 5, 6, 7. Now if we were doing an ellipse, we would connect these in a circular manner. But for a hyperbola, we're not going to do that. We're going to take this and we're going to make basically a dotted line box where those are all the sides of the rectangle. And then through that dotted line, it says draw slant asymptotes. It means through the center and the corners, you draw basically as an asymptote. These are guidelines for your hyperbola, much like a rational function would have. You draw your guidelines here. Now, which one is first? X. It means it's opening in the left and right direction. You start at the points that are on the left and right side, so these 2 points. And your graph is going to follow, kind of like a parabola shape, and go up towards the asymptote on either side. So it makes kind of a double-sided looking parabola shape. And this is how you sketch a hyperbola. So sketching an ellipse would have been the same. You do those same 4 points, but instead you connect them in kind of like a rounded shape. So I think hyperbolas are actually kind of interesting. If the y had led first, but they had the same numbers underneath, instead of doing the left and right side, we would have started from the top and bottom and sketched on the top and bottom. So that's the difference here in which term leads. So in 4a, the y term leads, so you should be sketching up and down. So this is all for 10.1. I know most of you are probably working on your test right now, so go ahead and work on your tests. I will grade them as soon as possible, and you can get to this when you need to. It's kind of an interesting thing. Remember, this isn't going to be on the final. So just, yeah, have fun. See you next time.